Hello and welcome back to the tied-up video demonstrations of basic physics concepts. In this video, we discuss about some interesting features of the position and displacement vectors. Let us begin with representation of displacement vector in the Cartesian coordinate system. To better understand this, imagine that your car is at location A in a highway, and it is moved to a location B in a given time interval. In order to define its position vector, we may have to define and fix a coordinate system first. Depending on this choice, the position vector of A and B will be different. For example, a stationary observer standing near the highway measures the position A of the car as 1I plus 2j meters from him, for a given instant. He measures position B of car as 5I plus 2j meters at a later time. When we say this, we are automatically fixing a coordinate system with the observer and assume that he sits at the origin, O, of the axes. With his measurement of the position vectors of location A and B, he can say that the displacement of the car is 4I meters, which is the vector difference of the final position vector and the initial position vector. Now imagine that we are moving the coordinate system close to the initial position A, so that we can imagine that the car is moving along the x-axis in the positive I direction. Now we can see that fixing a coordinate at such a location will help us visualizing the motion and displacement along the x-axis. An observer, now sitting at the origin O, of this displaced coordinate system, measures the initial position vector as 0I plus 0j and final position vector as 4I plus 0j meters. In this case also we can see that the displacement vector is the same. Now imagine that we are moving the coordinate system close to the final position B, so that we can imagine that the car is moving along the x-axis, in the positive direction towards the observer. The observer now sitting at the origin O, of this displaced coordinate system, and measures the initial position vector as minus 4I plus 0j, and final position vector as 0I plus 0j meters. In this case also, we can see that the displacement vector is the same. So we can conclude that, for a stationary observer, the position vectors he measured changes with his coordinates, but the displacement vector he measures will be independent of his location. In another way, we can say that two stationary observers, sitting at two different locations will measure different position vectors for the same object, when the object is moved from one location to another. However, the displacement vector measured by both observers will be the same. Since they measure same displacement vector in the same time period, the average velocity of motion measured by two stationary observers will be the same. This statement is not true when the observers and their coordinate system fixed to them are moving with constant velocities. Such a case, the velocity measurement will lead to the concept of relative velocity and resultant velocity, which will be discussed next. Thank you for listening.